saying, the plants were able to form how they normally would. So they were able to grow the pods and pegs as well as contain the seeds in those pods, and same seeds that you could just buy at the store. Tomato performed the best in Virginia across our growth parameters. So in terms of width, height, and the amount of pegs and pods to form. And then after tomato, we had lemon perform the second best with a decent height as well as crown width. Here we have a heat map of survivability. So like I said, we did have 3 replicates. The control, as you can see, was able to perform across our botanical groups. And then Virginia was able to respond the most across our different treatments. The 100% means 3 out of 3 of the cuttings we did were able to successfully grow roots. And 67%, 2 out of 3 of the cuttings. And then 33%, 1 out of 3 of the cuttings. And then we have some where no roots formed, and so we have 0%. This data represents some of the growth parameters for our top performers. So our control, tomato, and lemon. Tomato had the highest plant height. Control had the widest crown width. And then tomato had the largest amount of pegs and pods to form in the plant cutting. So overall, this study was successful and has the potential to be impactful in peanut farming. This study supports our hypothesis that during that healing process or wound healing process, some of the biological substances are being perceived as signals not only to heal the plant, but to induce roots as well. Most of the differences in this study were due to genetic differences between the different plants we use or different peanuts we use. The best performer across the board was Virginia, which it echoes to a separate study we did at Langston involving peanut production. So Virginia performed the best with this propagation study, as well as a separate study with production. And despite that, zucchini was the only treatment not able to induce roots in the Virginia variety. It was able to induce roots in 2 and 3 treatments that cause root formation in the runner and Spanish varieties. And this study basically lays the groundwork for follow-up studies so we can begin standardizing this protocol and these methods. Overall, this experiment was successful. It demonstrates for the first time that this macro propagation method can be used in peanut. And these results could expand to other crops eventually. Here are some of my references. I thank you all for your attendance, and thank you to my team at Langston University. I appreciate y'all. Thank you. Oh, sorry.
I saw that you have used Van Whitney and Crystal Wallace, right?
Yes, sir. Yes.
Under what context did you use Van Whitney, and under what context did you use Crystal Wallace?
Yes.
Did you do a follow-up after your Crystal Wallace? Did you do a Dunn's test as a follow-up pairwise comparison? Did you do that?
Initially, we did the parametric tests, so ANOVA and t-tests. We didn't find any significant data, so that's why we chose to use the non-parametric tests. And this was for the crown width, plant height, as well as the amount of pegs and pods. And no, we did not use a follow-up after these 2.
I think you are supposed to do post-hoc comparison, right? Once you find the significance in, let's say, Crystal Wallace, you need to do that Dunn's test, right?
Yes. At this time, yeah, we did not perform this, or at least we didn't include it in this slide. So.
Okay, I saw one of your slides for yield. When I look at the yield, looks like the plant, we're the one with pods. Yeah.
Oh,
Okay, looks like the yield might not be greater than actually yield coming from seedling.
okay.
So how can you then convince farmers or all of us here that this might be something better?
I see. Well, this is the initial study. So we were just trying to see if this is something that could actually work. And we didn't have yield in mind at the time when we formed this experiment. But I will say the pods that are forming, those represent one branch from a peanut plant. So the number may seem smaller or smaller than normal method, but if you multiply, like, let's say the Spanish variety typically has 7 branches. So if we had 7 pods form on that plant from one branch, then if we had that times 7, we're getting about over 40 pods that would form, which is about the normal amount per plant, or the average is usually at the lowest 40 pods per peanut plant. So eventually, as we begin standardizing this and improving this method, we will get to the point of a higher yield. And like I said, yeah, that it just represents one of those branches. So that answers your question.